Okay, we're back. This is Math 200. We're looking at Chapter 6. We're factoring trinomials, and specifically we're in 6.2. So that's page 4 on your note packet. So let's jump in. They have one explained where they're looking at combinations, things that multiply to be 30, but that add to be 13. And you kind of write those out. So when I learned how to do this, I kind of thought of those as suspects. Like it's a mystery that you're going to solve. And so look, things that multiply to be positive 24, but that add to be a negative 11. So when I build my list of suspects here, the only way I can multiply to get a positive, but add to be a negative, is if they're both negative. So negative 1 and negative 24, or negative 2 and negative 12, or negative 3 and negative 8, or negative 4 and negative 6. Those are all the things that multiply to be positive 24, but that could add up to be a negative 11. Now this one is out because it adds up to negative 25, so that's not a suspect anymore. This one is out because that adds up to negative 14. We need it to be negative 11. This one did it. Negative 3 and negative 8, when you add those together, you get negative 11, and when you multiply them, you get positive 24. So it fits the bill. It multiplies to be this number and adds to be that number. And so we break it into a binomial times a binomial. X times x is x squared, minus 3 minus 8. It doesn't matter if you write minus 8 first and minus 3 second. That's it. So that's factored. So we took a second degree trinomial and we broke it into a first degree binomial times another first degree binomial. Okay? That's factoring. We're really doing the same thing that you did when you broke things down into their prime factorization, like when you did 24 and you broke that down into 2 times 12 and 2 times 6 and then 2 times 3. 2 times 2 times 2 times 3. We took 24 and we broke it down into its base prime components. That's what multiplies to be 24, all the little pieces. That's what we're doing here. We're just doing it on an abstract level because there's a second degree variable here and a first degree variable there. So we're breaking this down into its smaller pieces, into its smaller components, just like what you did there. All right, let's look at number 2. X squared minus 2x minus 35. So now we're looking for suspects. Our list of suspects is going to be a negative 35. So we're looking at negative 1 and 35. But now every one that you think of, there's actually 2, because that could also be negative 35 and positive 1. Negative 5 and 7, negative 7 and 5. So not a lot there. Now, you've got to be cautious with this because students jump to this one and go, oh, negative 5 and 7. Well, let's check it. Negative 5 plus positive 7 is positive 2. We need it to be a negative 2. So it's got to be negative 7 and positive 5. I used to say they're twins, but he has an alibi. That's not the one we want because it adds up to positive 2. This is the one we want. All right. So x minus 7, x plus 5. On to the next page. So what about if they have a number out front like this? So now this can be a very difficult problem, but it doesn't necessarily have to be. So look, they have a 3 here. That could be a problem where we might have to do the AC method, but in this case it isn't because I can factor greatest common factor out a 3, right? A 3 will come out of there, a 3 will come out of there, and a 3 will come out of there. So if I pull a 3 out, I factor out the greatest common factor. Remember, I write it down, I put an empty set of parentheses, now I divide, divide, divide. Now look at what happens. I end up with m squared minus 8m minus 20. So now, forget about the 3 for right now, just put it out of your memory. And look, we have m squared minus 8m minus 20. That is just like that one and just like that one. So list of suspects for negative 20. That is anything that multiplies to be negative 20. Negative 1 and 20, negative 20 and 1, negative 2 and 10, negative 10 and 2, negative 5 and 4, negative 4 and 5. That's everything I can think of that multiplies to be negative 20. Now, only one of them did it. Nope, that's positive 19. That one added is negative 19. That's positive 8. Oh, almost negative 8 right there. There it is. All right. And so we'll split that into two parentheses. M times m is m squared, and minus 10 and plus 2. It doesn't matter if you put the plus 2 first and the minus 10 second, but the minus has to be on the 10 and the plus has to be on the 2. Otherwise, you won't get negative 8. If you switch the sign around, you'll get positive 8. All right. And there we have it. So that is, a lot of times this is referred to as unfoil factoring, like because you're opposite of first outer and last. You're kind of pulling them apart. All right. So now on this next one, let's take a look at number 4 is very complicated, and that one, it is factorable. I'm going to show you the AC method really quick, so kind of a preview of the AC method, because I want to kind of tie it in to what we did here. Factoring, I don't know why those little pieces won't erase. I don't know what's going on with that. All right, so let's take a look. We got 6x squared y squared minus 2xy squared minus 60y squared, and they already factored out the 2y squared for us. But that still leaves us a pretty difficult problem, because this 3 is here. I can't do just unfoil factoring. I can't just think what multiplies to be negative 30 and adds up to be negative 1. It won't work because this 3 kind of messed up everything. So what you have to do there, it's called the AC method. And the reason it's called the AC method is because in standard form, we have ax squared plus bx plus c. So AC method, it comes from, you take the coefficient of the x squared term, the coefficient of the leading coefficient, the one with the biggest power on it, times the one with no no variable on it at all. All right, and so 3 times negative 30, AC. That's why they call it the AC method. So that's negative 90. Now, after you do that, after you multiply the first thing times the last thing and you get negative 90, now we do our list of suspects, just like how we did before. So you think of everything that multiplies to be negative 90, negative 1 and 90, negative 90 and 1, negative 2 and 45, negative 45 and 2, negative 3 and 30, negative 30 and 3, negative 10 and 9, negative 9 and 10. I think that's everything. Oh, there's a 15 in there. Do we have to worry about that? We don't have to worry about that because look, here it is, negative 10 and 9. That multiplies to be negative 90, but adds up to be negative 1. So now, and this is a little complicated, it's a little more complicated than just factoring, unfoil factoring. Because when we were unfoil factoring, we were done. When we found that combination that multiplied to be that and added to be that, we were done. Here, we're not done. We're going to substitute that in. We're going to put in a negative 10x plus 9x, and that is negative 1x. And then we're going to bring down the negative 30 and the 3x squared. The 2y squared is still out front. But now, see what we did was we broke it from a trinomial. It's still really officially a trinomial, but we've split that middle term into two more terms, two different terms. We could combine those like terms, it would still be negative 1. Don't do that. The idea of finding this combination and putting it in there, substituting it in, is so now you got 1, 2, 3, 4 terms, and we're going to do a factor by grouping method. So we're going to pull something out of the first two, pull something out of the second two, and then you should be left with the same binomial to pull out. So let's take a look at what that looks like. 2i squared. So out of the first two, I can factor out an x. So I factor out an x, I do an empty set of parentheses, I put an x there and x there, and we get 3x minus 10. On the second two, I can factor out 3. And so I put a 3 under there, 3 under there, I reduce it, 3x, I reduce it, 10. and minus comes down. And now check it out. Look, I got 3x minus 10 there. I got 3x minus 10 there. So I can factor that out. And so now since it's x times 3x minus 10 divided by 3x minus 10, those cancel. This is my greatest common factor. I pulled it out front, empty set of parentheses. Now I'm filling in that. So when those cancel, I get just x. That's where that x came from. Those cancel, I get just 3. That's where the 3 came from. And the plus stays a plus, and the 2i squared is still there. And so now this is completely factored. That is the factored form. All right. So not a walk in the park in any means, all right? Let's take a quick look at number 5. We got x squared minus 6x plus 10. And so you want a list of everything that multiplies to be positive 10 but adds to be a negative. So it's got to be negative, negative. Negative 1, negative 10, negative 2, negative 5. That's it. So that adds up to negative 11, that adds up to negative 7. Neither one of them is negative 6. If you cannot factor something, then we call it prime. So remember when we had numbers that we were breaking down, like the 24 that we broke down into its prime factorization? If I gave you 17, you didn't break down 17. 17 was called a prime number. This is called a prime trinomial. You can't do anything with it because nothing multiplies to give you positive 10 and adds up to give you negative 6. So if it cannot be factored, it's called prime. All right? Okay. So let's take a look at page 6. And I think we're going to end up breaking this video into 2 parts. We'll do this last one, because then the rest of them are going to be the AC method ones, and those take a little more time. Okay, so here we are. If it's a perfect square like 25x squared and a perfect square like 4, give this a try first. Like take the square root of it and take the square root of it and see if that works, if it's a perfect square. If they tell you it's a perfect square trinomial, then you can just do this and you'll be done. But let's do the 5x plus 2 and the 5x plus 2. All right? And so let's check the middle, basically. So we know for sure 5x times 5x is 25x squared. That's what we did with the square root. We know for sure that 2 times 2 is 4. So we've got the first one nailed and the last one nailed. But we have to have all of our ducks in a row, meaning the middle term has to add up to 20x, which means, remember, when we do the distributive property there, we get 10x. And when we do the distributive property there, we get 10x. And we combine those together. So 10x plus 10x is 20x. So that does work. It turned out to be a perfect square trinomial. So this times that. You could write it like this if you wanted to be fancy. That's fine. That's the same thing. All right. If they tell you ahead of time that it's a perfect square trinomial, then you don't have to, no worries then. Then you can just do the square roots and the middle will always work out. Because a perfect square trinomial means that it's the same thing times itself. Just like a perfect square number. Like if I told you 49, that is 7 times 7, right? That's a perfect square. All right. Okay, so that's 15 minutes. Let's see. Yeah, we'll do a part 2.